In this video, we're going to take a look at a differentiation rule called the quotient rule. And what the quotient rule allows us to do is when given a function in the form f of x divided by g of x, the derivative with respect to x of f of x divided by g of x will be given by the following formula. Now, before we get to that formula, I want to highlight that what I'm going to write down, the order of this formula matters. And we'll get back to what I mean by that in a second here. So our derivative will be g of x times f prime of x minus f of x times g prime of x all over g of x quantity squared. And this is why the order matters. In that numerator, we have subtraction, which means g times f prime, or the bottom function times derivative of the top, must always come first. And so it gets a little bit tricky with this more complicated formula to try to lock that into memory. So one little trick that could help is to label your top function as the high function and your bottom function as the low function, and use this slightly easier to remember format. Low d high, or low times derivative of the high function, minus high d low, the high function times derivative of the low function, all over low squared. Again, just one way that you can try to get down the order that you need to follow on the quotient rule, and you might be able to come up with even a better way to memorize this, but the important thing is to find a way to memorize this rule and make sure we don't flip the order of the two terms in the numerator. So let's look at an example that will involve quotient rule. We'll set up h of x equals sine of x over x. And an organizational tip for this is to separate your two functions right away. Your high function being sine of x, and your low function is just x. And differentiating those both before you start. So the derivative of sine of x is cosine of x, and the derivative of x is just 1. Because now we can jump straight into just putting these terms into the formula. So low times derivative of the high function will be x times cosine of x, minus high times derivative of the low, sine of x times 1, all over the low function squared, which is just x squared. And simplifying here, most of it's just dropping parentheses on this one. This would just be x cosine of x minus sine of x all over x squared. And not much else we can do with that. We're going to leave it the way it is. You could look for things to factor out and cancel. You look for maybe like terms in the numerator, but we don't have any of that here. And so the formula is a little bit more complicated looking than any other derivative rule you probably would have seen to this point. So last thing I want to highlight is when it's necessary to use this rule and when it's not necessary to use this rule. Because if we can avoid a more complicated formula, that would be ideal. We would want to do that. So a necessary problem. Something like this k of x equals the natural log of x divided by x to the third power. Notice those two functions are not in the same function family. We cannot possibly simplify this quotient down. It's always going to be natural log of x divided by x cubed. So we'll set up our high and low functions. High function's natural log of x, low function's x cubed. The derivative of natural log of x is 1 over x, and the derivative of x cubed is 3x squared. And we have everything we need to jump into the formula. Our derivative, applying the quotient rule, will be x to the third power times 1 over x minus the natural log of x times 3x squared all over that bottom function squared, in this case x cubed to the second power. And this one we can do some simplifying. The x cubed times 1 over x, or x cubed divided by x, would just be x squared. Minus 3x squared times natural log of x, we'll move the polynomial out in front, just to standardize, and the denominator will become x to the 6th power. Now notice, you could factor out an x squared from both terms of the numerator, which means we can cancel it out with an x squared from the denominator and end up with something slightly simpler. We could end up with 1 minus 3 natural log of x all over x to the fourth. And any of these forms are fine. Again, simplifying will serve its purpose at some point. Right now you're focused on just getting used to the rule and recognizing when to use it. So let's look at where it's not going to be necessary to use this rule. Let's set up a function like m of x equals the cube root of x over x. Now, in this form, we could rewrite this problem. We could rewrite this as x to the 1/3 over x, and using exponent laws, this would simplify to x to the negative 2/3 power, which means we can just apply the power rule to this problem instead, and get m prime of x equals negative 2/3 x to the negative 5/3, which we can then rewrite as negative 2 over 3x to the 5/3 power. If you applied quotient rule, simplified as far as you could, you would get the same exact expression, something equivalent to it, but it's going to take a lot more steps, and that formula is a tad more intricate than anything else you're going to deal with, so it leaves more room for errors that we would like to avoid if we can. And all that's left to do now is getting used to applying quotient rule and knowing when to apply it. Thank you for watching.